Okay, this is question number 70, and I'm going to use this to illustrate how you would determine the name of an amine. So in this case, if we look at this functional group, what we have is we have an amine, we have the amine functional group, we've got an alkene, and we have an alkoxy group. Of those, if we go to our chart, we can see that the amine has the highest priority, and then the double bond, and then finally the alkoxy group. So if we're laying out the priorities, the amine is going to be the number one priority, and then alkene will be number two. The alkoxy is going to rank the same way as the bromo and the alkyl group here. Okay, so look, when you have an amine, the first thing is that the final name in the molecule will be amine because it'll be the last suffix, which is true for all high priority groups. Now, in order to name the alkene, what we have to do is look at the three groups that are attached to it. So I've got a methyl, I've got an ethyl, and I have this entire longest chain. And so that longest chain then becomes the parent name. So the one that has the most carbons is the one that's going to become the parent chain. So that means that this group, including the double bond, is going to be the longest chain in the molecule. Now, what happens to the other two groups is they are named as substituents on the nitrogen. But here's how we do that. What we say for this group right here is this becomes an N-methyl. And what that means is there's a methyl group attached to the nitrogen. This group then is named as an N-ethyl group, because again, it's an ethyl group attached to the nitrogen. And so now that we have these substituents, we're going to use those in our name as we name the rest of the parent chain. Okay, since the amine has the highest priority, it gets the numbering scheme preference to it. So in other words, number the parent chain from the end closest to the nitrogen. So this becomes number 1, number 2, number 3, number 4, 5, 6, 7, 8, and 9. Okay, so this is going to become then, in terms of our parent name, this is going to be a non. Then I'm going to need the number of the double bond, and then the number of where the amine is, which in this case is attached to carbon 1. So the double bond is at 3, so the parent name of this is going to become a non-3-ene 1-amine. So 1-amine because the amine is the highest priority and comes last. The non being the total number of carbons, and then the 3-ene being the fact that there's a double bond in the parent chain. If this was all single bonds, this would become a non-ane 1-amine. And if there was a triple bond, it would be a non with a number ine 1-amine. So it's again using our formula of total number of carbons, whether there's a single, double, or triple bond in the molecule, and then the suffix of the highest priority group. Now, as far as the rest of this goes, we have a bromo at 2, so we've got a 2-bromo. We have, so that takes care of that one. We have this group right here, which would be a carbon with 3 CH3s. And so that's going to be a 3-tertiary butyl. because it's alphabetized on B. Then this group over here is an alkoxy where there's a methyl group, so this is going to be a methoxy group. And that is the last substituent. Well, that's the last substituent, except for the N-methyl and N-ethyl. So now we're going to alphabetize the N-ethyl, so it goes N-ethyl because of the E. Then methoxy versus methyl. Methoxy comes first, so that's going to be a 6-methoxy. And then the methyl group, so now we have an N-methyl. And that now is including all of the substituent names. So the name of this molecule would be 2-bromo-3-tertibutyl N-ethyl 6-methoxy and methyl non-3-ene 1-amine. Okay. And so hopefully that's the correct answer. 2-bromo-3-tertibutyl N-ethyl 6-methoxy and methyl non-3-ene 1-amine. Now there is an E or Z. There is an E or Z in front of this, but we haven't talked about E or Z yet, and so we'll hold off on that. So that is the correct answer as given in the textbook. So that's how we put together that name. Now looking at